to the next problem. An isosceles triangular plate of negligible thickness has base 25 mm long and altitude means height 35 mm. It is placed on HP such that in the front view is seen as an equilateral triangle of 25 mm. The side 25 mm side with the side that is parallel to VP is inclined at 45 degrees to HP. Draw its top and front views. Also determine the inclination of the plate with the reference plane. So again, first condition is an isosceles triangular plate of negligible thickness has 25 mm base and altitude 35 mm. It is placed on HP. So we are considered it placed on HP. So since he says it is placed on HP such that its front view is seen as an equilateral triangle. So naturally we have to start from the HP. So we have taken from the horizontal plane. So that means keeping C dash on HP. So keeping C, capital C on HP. So it is parallel to VP. So you can see a true shape here. And when you look from the top view, surface is perpendicular. So you are getting a line here. Now, so this is the initial position. So here a base of 25 mm side and altitude means height. So that is 35 mm. So what you have to do is first you draw a vertical line and consider any point here on the XY line. From here you mark 25 to get this line. Then take the midpoint of 25, that is 12.5, and you mark the point. And then draw a line which is perpendicular to this vertical line. Then measure the length of 35 mm and by using the compass. From here you cut an arc on this horizontal line to get this point A dash. So this is C dash and this is B dash. So when you look from the 2D, you can see draw a vertical line here. Consider C dash. From here you mark 25 and take 12.5 and draw a horizontal line. And from here you measure 35 and mark this point A dash. Then join this and join this to get an isosceles triangle. Since it is parallel to VP, so I am getting the true shape here. Since it is perpendicular to HP, I am getting a line here. And you take any convenient distance between these two. This has been considered only because I to give the clarity in 3 dimension. You can take it here also, and from here you rotate it away from VP. But now what I have done is I have rotated towards VP. So that is the only difference between the two. You can take it like that also. So now in the second position, it has been rotated such that the front view is seen as an equilateral triangle. So here in the second position, so what you have to do is first you draw a vertical line here which is 25 mm. It's an equilateral triangle. So obviously this side also 25. Then what you do is you measure 25 mm through B dash, draw a horizontal projector from A dash. From B dash you cut an arc on this horizontal projector to get this point here. Similarly from C dash you measure 25 mm and cut an arc on this. So both the arc will coincide. Then you are going to get the equilateral triangle of 25 mm side. So you got this point here which is already here. Then what you do, you draw a vertical projector from A dash. Then measure the length from B to A which is 35 mm. From B you cut an arc on this. You will get a line here. So this is the surface inclination with respect to the vertical plane. So this is the surface inclination what I am looking at. Okay. So which is 51.79 degrees. Or obviously when you are doing it manually it will going to become 52. So this is an equilateral triangle. And here this side which is resting on HP is parallel to VP here. Since it is parallel to VP, because if you see when you look from the top view, both B and C are at equidistant from the vertical plane. So obviously this is parallel to VP. So I am getting the true length in VP. That means whatever the distance is there from B to C here, the same distance will be there here also. So obviously that will be parallel to VP. So now this is the one which will going to be in true length B dash C dash. Then with the side that is parallel to VP, so the side which is parallel to VP is BC, is inclined at 45 degrees to HP. So parallel to VP is inclined at 45 degrees to HP means it is a true inclination. So the length what you have B dash C dash is also true length. So what you have to do is you rotate this by an angle of 45 degree. So consider C dash on XY line. and draw a line which is inclined at 45 degrees. Then measure the length from C dash to B dash. From C dash you draw, from C dash you cut an arc on this to get this B dash C dash. Since it is an equilateral triangle, from C dash you draw an arc, and from B dash you cut the previously drawn arc. So this is how I can reproduce this sketch at an angle of 45 degrees. Basically, because since it is parallel to VP, I am getting the true length here. The inclination given is also true inclination. First you draw a 45 degree line, measure the length from C dash to B dash. From C dash you cut an arc on this to get the point B dash, and through C dash you draw an arc here, and from B dash you cut this arc, because all are equal, all the sides are equal, so it's an equilateral triangle. Then you draw a horizontal projection from BC and draw a vertical projector from C dash and B dash to get this line, and then draw a vertical projector from A and draw a horizontal projector from A in the second position to get the point A and join this. But still you can see the edge which is inclined at 45 degrees to HP will be parallel to VP. And then one of the, it is the front view is seen as an equilateral triangle. So this front view is an equilateral triangle, which is when you are going to get an equilateral triangle, when it is rotated by a certain angle. What is that angle? Which will be phi is equal to 51.79, because that is, we have to determine the inclination of the plate with the reference plane. So it is inclined to VP but perpendicular to HP, so you are getting a line. And then it is resting on HP such that of a 25 mm base, and this is the height which will going to be 35 mm, which is an isosceles triangle. So this is how you can analyze the 3 dimension. You can see here still the C is resting on HP, and this is the actual view in the third 3 dimension. When you are looking, actual piece will be look like this, but when it is projected, when you look from the front view, this will going to be the position, and when you look from the top view, this will going to be the figure. This figure will be equivalent to this, and this figure will be equivalent to this. So finally, when you are doing it in 2D analysis also, the same what we have done, what we have explained so far, which is going to be here. So it is a 25 mm side, and this is height of 35 mm altitude, and you will going to get this is the parallel to VP, so you are getting the true shape here, and this is perpendicular to HP. In HP you are getting a line. Then it is rotated such that until it becomes a equilateral triangle of 25 mm. So this side is also 25, this side is also 25, and this side is also 25. So you will get this. Draw a vertical projector from BC and draw a horizontal projector from BC, you will get this point. And then draw a vertical projector, and when you are going to be got 25 mm square, this line is rotated. So how much it is rotation angle? From here, measure the length from B to A. From B you cut an arc on this vertical projector to get the point A. Then you measure this angle. That angle is nothing but 51.79, but this computer, but when it is doing it in manual, we are going to get 52 degrees. The side which is on HP is inclined at 45 degrees to VP. So which is that B dash C dash, which is BC, which is parallel to VP. So I am getting the true length here, and the inclination given is also true inclination. So you draw a line inclined at 45 degree and measure the length from C dash to B dash. From C dash you cut an arc. Then through C dash you draw one more arc, and through B dash you cut the previous arc, because all the dimensions are equivalent to 25. It's an equilateral triangle. Then project this to get the corresponding top view. So that is how we will going to solve this problem.